Greetings, this is Professor Tom Wolf. Now that we're in Computer Programming 2, we're looking at using objects. And so one of the things I'm going to talk about now is how we can take an existing program and refactor it to use object-oriented design. So we're going to use our Tic Tac Toe game because most people find that interesting and it's fairly complex, so it's a fairly good example to play with. Okay, so we're using an approach to teaching Java called late objects. So at this point in the course, in Computer Programming 2, we're just starting to learn about how to create objects and do object-oriented design. And that's not the only way Java is taught. Some people teach what's called objects early, but the objects late works better for us because some of our students only do the procedural part of the program in CP1. Okay, let's go ahead and refactor the Tic Tac Toe game. Hopefully you're already familiar with the console version of this that we did in CP1 and how class files work. So I'm assuming that you know the basics of how to create the class files already. If you watch these in order, it won't be a problem. Okay, so we played Tic Tac Toe, we built it. We look at the game, we can kind of create a list of things that are in the game. So one thing right off in the game is you have a player and you have a board that represents the surface and really the status and the state of the game. And then we also have things like moves and ties and wins and things like that. And so if we percolate this a while, we can kind of come up with a pattern that we have these two objects, a player and a board. Player is a trivial object. It's really just a string variable. It's either X or O, so we're not going to write a class to do that. Board, on the other hand, is a fairly sophisticated data object. So the board has the 9 compartments. It has some related methods that are tied to it. So for instance, we need to use the board to determine if there's a win, and we have sub-methods that use the board to add to that. Similarly with the tie, checking for a valid move. We also have some more action type verbs. Clear the board will reset the board. We have to be able to do that. We have a display board method that we need to use as well. So all these methods kind of connect to board, and so it sort of makes sense that we go ahead and create a class called board and we lump them together, and that's what the class will let us do. Okay, so let's just go ahead and get into NetBeans and see what we can do here. Okay, so I have my original Tic Tac Toe game here, and it has safe input, which is our input library, and it has Tic Tac Toe Java, which is the entire game. Then I've created a new NetBeans project called Tic Tac Toe Object Oriented Design Refactor 01. And this first refactoring, I'm just going to create a class that represents the board, but you'll see that one time I can do one more refinement and I can create a game class too, and there's some advantage to that. Well, we'll just take care of the first one in this one. Okay, so I'm going to need safe input, and I might as well copy the Tic Tac Toe and then start editing it. So I'm going to copy both of those and paste them into the new project, and we can just copy that. We don't have to refactor. Okay, now we already decided we're going to make a board, so let's go ahead and go new Java class, and we're going to call this TTTBoard because it's a board specifically for a Tic Tac Toe game, and then we'll finish. So let's go ahead and fix our Egyptian braces here, and can expand this a little bit. So this is a regular class, not a main class. It's an object class. So this is how I define objects. And so we already have what we need in Tic Tac Toe. So let's double click and open this. And you can see the first thing we have are the symbolic constants, row and column, and the definition of board. So let's copy this. And I'm actually going to go ahead and delete it from Tic Tac Toe. And I'll put it into TTTBoard. Okay. Alright, that's good. So what this does is defines those two constants, row and column. They'll never change. And then it creates a string two-dimensional array called board, which is 3 by 3. And what we can store in there is the X, the O, or the space. Okay? Alright. These are private. They shouldn't be static, though. Oops, this can be static. I'm sorry. But this should not be static. So basically, there's one copy of the symbolic constants, which we call a global, for the entire class, but this is not to be static. The reason it's not static is every time we create an instance of this, every board, it'll therefore have its own board array. And if it was static, it would imply that there was one that was being shared by the entire class. Every time we created an instance, it would still use that shared board. That probably wouldn't work very well. Okay. All the rest of the stuff in here are the functions that we already developed. So we want to clear the board, determine if there's a win, all that. So we can go back over here to Tic Tac Toe again. And I'm just going to start carving this up. Now notice that I'm leaving this loop here. So the actual game is what is in main. What I'm going to copy are all of these methods. So I'll go all the way down to the bottom of the file. And we'll take a quick look at these in a second. I'm just going to copy them now. Because one of the things I'm trying to show you is that I am actually refactoring. So because I had written this material in a fairly clever way, I'm going to go ahead and delete it while I'm here. Go back to TTTBoard and paste it back in. Because I had written it in a fairly clever way, we can refactor it pretty well. And that just comes from experience, but you want to kind of think about that when you're doing your programs. Okay, so right off here now we have to start talking about some of these things. These are not going to be static. We just have one method. I didn't say that very well. They're not going to be static. When you have static methods, that's usually when you have a static class where you never create an instance of the object. Here, these are just standard methods. Every object will have the ability to clear its board. Also, for that to work, they have to be public. So, for instance, if I have I create a board called game, and then I want game to clear itself, I would say game.clearBoard. But if that was private, I wouldn't be allowed to do that. Then it would be internal. It can only be used inside of the board file. So that's got to be public. This one also has to be public. And of course not static again. Whoops. Public void. Oh, that's fine. Okay. What do we got here? This one has to be public and not static. Let's see, is when. Yep, that's still public. Now, here are the helper methods. These actually are private, but they're not static. So get rid of this. Oops, made a little error there. again, static methods are going to be in a class that never gets instantiated, and that's usually main, or that's a class that has only static methods. Oops, wrong. This is private. And boolean. Oh, I had that one. Being silly here. Let's see. Okay, let's get this one. You can see it fixes too. The compiler is like, oh, okay, now I know what you meant. Okay, so these are all the helper methods for our determine if there's a win or not. That's got to be, yeah, that's also a helper method, so that's still private. And then I think we should have a couple that are public. Yeah, so isTie is a public method, and it's not static. I think we're about done here. I have to fix. Okay, so far so good. So we'll save that, Control S. And now let's pop back here to Tic Tac Toe. So now what's left in Tic Tac Toe is the game. So this is actually the logic for the game. And the mechanism of the scanner and using the safe input to get the input. So instead of having the board here, now we have to create a board object. So let's go ahead now and start to alter the main so that we can use our new class. So the name of my class is TTTBoard. You can say that's its type. So TTTBoard. Now I'm going to call this board, because that'll work real well with the code that I already have, equals new TTTBoard. And that'll create the TTT board. Now unfortunately though, I'm jumping the gun. We're not ready for that. Let's go back to our TTT board, and we have to create a constructor. So what we have now is, whoops, we're in the wrong file. Oh, that's it. Okay. Okay, so we have to create a special function called a constructor. I like to put my constructor up at the top after the instance variables, and the constructor is going to let's see, is that a return type? I think it does. No, maybe not. We'll see. Oh, I almost forgot. We want to just let NetBeans do this for us. So right click here, say Refactor. Oops, sorry, Refactor. Oh, well, I could use insert code. That's probably what I wanted anyway. Whoops. Insert code. There we go. Generate constructor. Okay. So there's the basic constructor. And one of the things we want to do here is we want to go ahead and clear the board. So when we create a new Tic Tac Toe board, it will automatically be cleared. Okay. So now if we go back to our driver here, now I have a constructor. I'm almost there to where I can run this. So I've got this new element called board, which is of this type I've defined called TTTBoard. And now as I go down through here, clear board is actually a call to my instance. So I just have to add that into the code to refactor it. So board is the name of my instance, my actual Tic Tac Toe board. I create it here. And now I just have to go through and update the code and add this board.display. because now display is a method that belongs to a particular instance of an object. Okay. Let's see what's going on here. Row column. Oh, I have to add a new method here. Yeah, this is an interesting thing. I did have to write a new method. So what this is it assigns the move. So that basically is like set move. So we have to add that method. Let's go do that now. I had this worked through, and I'm re-recording this. Come out to be a little bit better. Okay, so this will have to be public. And it's going to be a void, and it's set move, and then it'll take an integer, which is the row, and an integer, which is the column, and then we just basically can say board. Oh, I forgot to put the player in as the parameter too. Nope, forgot a parameter. Whoa, what's that going to be? Player, right? Okay, and then let's add that in. And this is a string. So what do we tell the method? We tell it the row and the column and the player to set move. Okay. Alright, so let's go back in to Tic Tac Toe. And now this is going to be board dot set move. And then there's no indexing here. We just pass the row and the column as integers. And the player. Okay, and of course we have to uncomment this. Okay, we could probably put a comment in here. Record the move. Whoops. So that's what that does. And that's what the old code did, but it did it because it had direct access to the board data structure. And now it doesn't. We're using the object instead. Okay, let's come on down here. Is when, that's a board method again. So Control V, board dot is when. And again, Control V, board dot display. So again, calling those off of the object instance, whereas previously I didn't have an object. This main had all these its capabilities itself. And I mean, for a small implementation, that might be a good solution. But to do significant things, we need to learn how to structure our code. And so a lot of this is about that. Okay, I think we might even be ready to run this. Let's give it a shot and see. Let's see, run project, Tic Tac Toe. Oh, I wonder if that's the right one. Let me cancel that. This is the one that I want to run. Seems kind of slow. Okay, so you can see that our Tic Tac Toe board object is working, and it's displaying the board, and then the game itself, the Tic Tac Toe Java main, is running that. So enter move for X, enter row. Let's say 1, 1. And it's recorded correctly. And let's put O in the center at 2, 2. Okay. Alright. So I don't think I need to go through this. You don't need to watch me play Tic Tac Toe. But basically, I just finished refactoring my existing code. and now it uses the object. Now, if you're like me, you're like, well, what the hell did we get from that, Tom? So let's talk about that. It's not really immediately obvious, but what's good about this is we could break this down now. So if we're working with a group of people, we could have somebody define the interface for the board real quickly. Then we could write code assuming the board will behave in a certain way without having to know how it was implemented. Now here, this is still pretty simple, but I hope you can see that it also made a lot of sense to extract the board functionality out into an object. And as you can see, the object is a combination of data with the array and the information about the status of the game, and a bunch of methods that all use that data. So there's a kind of an integrity there within the design that it all